Good evening. Welcome to the live interaction section for week 3 of our course, Biomechanics, by Professor Vardhan. I am Manjunathan, your TA, research scholar from the Department of Applied Mechanics, IIT Madras. So, let's move on to the week 3's topics. So, in week 3's topics, we have the how force is developed in skeletal muscles. That is the main content that is being discussed in week 3. That is the basic force formation happening inside skeletal muscles. So there is one theory called sliding filament theory. How the chemical reactions or the biochemical elements inside our body is activating skeletal muscles, and how the force is being developed, and with respect to that, how the length of the muscle or the sarcomere is changing, and that is basically what helping us on every moment, each and every moment of our body. These kind of uh, these kind of biochemical interactions happening inside our cells, which led to the force production inside the skeletal muscle, and which is making each and every motion of our bodies as a real one. Apart from that, we will see some analysis of upper limb. That is simply saying arm. In upper limb, the main joints are shoulder, elbow, wrist, and finger joints, and how these joints move with respect to each other, and what kind of muscles are helping these motions. All those things, and we will be seeing this. You might have watched the videos, and we will be discuss the questions regarding to these topics in today's session. So just we can take a small recap of the sessions. So this is the sliding filament theory, where how a basically how the muscle contraction is happening inside our skeletal muscles. In muscle contraction, uh, the muscle contraction occurs when the thin filaments, so these blue lines, the thin filaments, which is called actin, slides over the thick filaments, that is the red filaments, myosin. And this will, when these blue, that is actin filaments, when they slide above these thick myosin filaments, the length of the muscle fiber will reduce, or shortening of the muscle fiber happens. So the one functional unit, that is this is one functional unit of the muscle, which is called a sarcomere. And here I have not shown it, but you might have seen the videos. There will be two Z lines. The portion between two Z lines is known as sarcomere. So these Z lines will be attached to the actin filaments, that is the thin filaments, and myosin is the red filaments or thick filaments that is lying in the center of the sarcomere. In resting state, the actin and myosin overlap partially, and the tropomyosin, the element called tropomyosin, blocks the myosin binding sites, and because of that, the binding of myosin, the actin could not bind with the myosin. When this motor neuron motor neuron excitation happens or some neural signals is triggered in a neuromuscular junction, there will be an action potential in the muscle fiber, and um, after that this calcium ions, Ca2 plus ions will be released by the sarcoplasmic reticulum, and this calcium binds with the troponin, uh, and this troponin binding will shift the tropomyosin and eventually exposing the myosin binding sites. So when the myosin binding sites are exposed, the energized myosin heads will attach the actin, and this will form some cross bridges, and these cross bridges will create a pulling action. Myosin head will create a pivoting action to the uh, with pulling the actin filaments towards the center of the sarcomere, and this will utilize the energy from ATP, adenine triphosphate, that will take that energy from this one and create a quick pivoting motion called power stroke. So this is basically the how this what is the biochemical base, or how the elements are, how the neurons excites the neuromuscular junction, and eventually which chemicals are being released, and how this uh, actin myosin bonding and unbonding is happening. That's simply saying the filaments are kind of sliding over each other due to the electrochemical uh, changes that is happening in the neuromuscular junction. That is how energy is produced and movements is occurring in the within the muscle cells. Then this is the diagram for force length relationship. From here, you can see how much force or how much force is being uh, there on different lengths of the sarcomere. So when these muscle fibers are uh, completely slide over each other, when the sarcomere length is very reduced, the force will be less, and how the uh, force is varying according to the length of the sarcomere. So this is one hot topic that is mostly used uh, that will be there in the final exams from this for this course actually. Then next was joints of the upper limb, that most of you already know what are the joints of upper limb. That is the shoulder joint, elbow joint, and wrist joint and finger joints. So these different joints we already discussed in the synovial joints in our body. That main types we have already discussed in the first interaction section. And in the entire course will be mostly handling upper body or upper limb dynamics. In later coming sessions and all, we will not be going much into other body parts. Most of the course is kind of centered around upper limbs. Even though when we are going to discuss the DH equations or uh, dynamic Hardenberg theory and all, we will be mostly discussing with the respect to upper limb only. So these are the main uh, joints and muscles uh, in the upper joint. This one is called where the clavicle and sternum is happening is called is sternoclavicular joint. This connects the upper limb with the axial skeleton, and the type of synovial joint is saddle joint. Next one, the distal end of the clavicle. That is, this is the medial end of the clavicle, and the lateral end of the clavicle is joined to the acromion, and the type of joint here is gliding joint or plane joint. So where the portion which is mostly people in layman language we tell as the wings or the back plate of the upper limb is called as scapula, and where this scapula is being joined or coming in contact with the rib cage is known as scapulothoracic joints. And this there is actually there is no as such joint is there. This is mostly uh, the contacts are being created by muscles only, and where the shoulder or hand is being attached to the body is by this glenohumeral joint, and this type of joint is the type of joint here is ball and socket joint, and these are the other major muscles in the upper hand. So we have already discussed about biceps muscle in the first session, I think. These are some the other muscles. The deltoid, which is the top portion of the hands. Then there is trapezius, pectoralis major. There is mostly where the extra support or additional support to the hands are being given from the medial portion of the body. That is from the chest side to hands. The force or attachments are being given through pectoralis major, and sternocleidomastoid is the neck muscles. Actually, it helps the supports the um, joints in the neck. So let's move on to the questions. There is much more. We have, I mean, much more topic is being discussed in week 3. I'm not going to uh, waste the time doing recapping all the things, and mostly I am not. I don't. I have not included the mechanics portion. That is the uh, end of the week 3 sessions. You have you might have seen these elbow problems, hand and elbow problems, weightlifting problem, all those things that we will not be discussing in our today's class, today's session. It will be discussed with the rest of the topics in the week 4. So let's start with the questions. Try to answer the question. I will give some brief period of time for you to think and answer. Even though the you don't know the answer, try to uh, guess with what you already know. So because even if you are getting it wrong here, you will remember the same for your exams. So first question: the excitation contraction coupling refers to which of the following? Options are conversion of chemical energy to heat, muscle fatigue mechanism, electrical signal triggering muscle contraction, tendon force transmission. So, what does excitation contraction coupling refers to? Conversion of chemical energy to heat, or is it muscle fatigue mechanism, or is it a electrical signal triggering muscle contraction, or tendon force transmission? You can inbox the answers. Please do answer the question. Yes, the answer is option third one. That is electrical signal. That is electrochemical reaction is being happening in a neuromuscular junction. When the neuronal excitation happens, is literally what is meaning is some electrical signal is being given to the neuromuscular junction, and from that electrical signal, the release of acetylcholine and calcium ions are being happens, which will uh, start the cascade. So this electrical signal from neurons, when it reaches the neuromuscular junction, the muscle contraction or excitation contraction coupling, that mechanism, this is actually cascade. That cascade meaning one event leading to another event. Uh, that is being actually happening there. Next question. Which ion plays a key role in the excitation contraction coupling? Is it sodium, potassium, calcium, chloride? So here the options are actually little more easier ones, but uh, you know there are more than one ions in play in excitation contraction coupling. So here the options are a little more easier, but sometimes it can become difficult also. So which ion plays a key role in excitation contraction coupling? You can just inbox the answers. So the answer is calcium or Ca2 plus ions, because when it is released from, when the excitation coupling uh, sorry, the electric, when the electrical signal hits the neuromuscular junction, that electrical excitation causes this sarcoplasmic reticulum to release calcium ions, and these calcium ions will bond with troponin, and which will expose tropomyosin. And major thing is like here the question, actually the keyword is key role. So even though there are sodium, potassium, phosphorus, all those terms will be there, but the thing is like which has more role. Here calcium, because the excitation contraction coupling will last as long as there is Ca2 plus ions and ATP, adenine triphosphate. Only when, as long as calcium and ATP are available, that cross bridge will continue and the contraction will be sustained. Once calcium ions are the calcium ions releasing has stopped or it decreases, that bond also decreases or breaks. So the main part is like uh, key role, so which has the important role. So calcium released during excitation contraction coupling occurs from, I just told the word. So is it mitochondria, Golgi apparatus, sarcoplasmic reticulum, T tubules? From where is the calcium 2 plus ions or calcium ions are released during excitation contraction coupling? Mitochondria, Golgi apparatus, sarcoplasmic reticulum, T tubules. So answer is, I just mentioned in the last slide itself, SR, that is sarcoplasmic reticulum. So can anyone say what will happen to the calcium Ca2 plus ions on the once the electrical signal stops or the stimulus stops? What will happen to Ca calcium ions when the electrical stimulus stops? You can think on that. So, what is the primary function of C disc or Z disc in the sarcomere structure? Actually, the interconnection of actin filaments uh, creates a structure for Z disc. So, what is the primary function of Z disc in sarcomere structure? Options are to generate ATP for muscle contraction, to anchor actin filaments and define the boundaries of sarcomere, to store calcium ions, to stabilize filaments, myosin filaments. Answer is option D or the second option, that is to anchor actin filaments and define boundaries of sarcomere. So the Z structure is happening only because when the actin filaments are coming into contact. So the cellulose structure occurs only because of the interconnection of actin filaments, and this uh, structure is actually giving an anchoring because this portion of the joining portion of uh, if you compare between the actin filaments and these connection points, the movement of actin filaments and movement of Z disc, because there will be very 0 to no, but very low to zero movement will be happening to these connections, while the movements will be happening inside the functional structure, that is the sarcomere. So that's why it's called an anchor also. Next question, another simple one. Troponins binds to which of the following ions to initiate muscle contraction? I have already explained that also. Troponin binds to which of the following ions to initiate muscle contraction? Sodium ions, potassium ions, magnesium ions, calcium ions. So we have just seen in the question before, second question itself, calcium binds with the troponin, and sorry, the troponin gets bonded with the calcium ions. That's why it's the calcium have multiple role. Uh, sorry, the major role of calcium itself is to bind with the troponin. Next question, which of the following statement is true about troponin and tropomyosin? So the statements are, Tropomyosin binds to calcium ions to regulate contraction. Second statement, troponin binds to myosin directly to initiate contraction. Troponin regulates the position of tropomyosin on actin filaments. Tropomyosin breaks down ATP to release energy for contraction. So the question is, which of the following statement is true about troponin and tropomyosin? Tropomyosin binds to calcium ions to regulate contraction. Troponin binds to myosin directly to initiate contraction. Troponin regulates the position of tropomyosin on actin filaments. Tropomyosin breaks down ATP to release energy for contraction. You can inbox the answers. Our answer is option C, or third option, that is troponin regulates the position of tropomyosin on actin filaments. Uh, no, it's not A actually. Here, tropomyosin does not binds with calcium. It's troponin that binds with calcium. Also, tropomyosin doesn't break down to release ATP. So calcium ions get attached to troponin, and once the troponin moves, it will shift the tropomyosin to expose the actin filaments or binding sites in the actin filaments. What causes the myosin head to detach from the actin after the power stroke? So what causes the myosin head to detach from actin after the power stroke? Options are binding of calcium to myosin, hydrolysis of ATP, release of ADP and PA, binding of new ATP molecule. So, what is the what caused the myosin head to detach from actin after the power stroke? The answer is fourth one, that is binding of new ATP molecule. When a new ATP molecule binds to myosin, it will detached from the actin. At very short sarcomere lengths, the muscle force generation is reduced because of which of the following? This question is kind of asked multiple times. So just options are actin filaments slide past M line, myosin heads cannot bind ATP, actin filaments overlap too much, interfering with the cross bridge formation. Last option, calcium release is inhibited. At very short sarcomere length, the muscle force generation is reduced because of which of the following? Actin filaments slide past M line, myosin heads cannot bind ATP, actin filaments overlap too much, interfering with cross bridge formation, calcium release is inhibited. Yes, when the at very short length, the actin filaments will be overlapping too much, and this will interfere with the cross bridge formation. So once the cross bridge formation is not happening, the muscle force generated will be reduced. Next question. Which of the following statement about active and passive force generation in muscle is/are are correct? Options are active force depends on ATP for cross bridge cycling. Passive force relies on contractile element in muscle. Passive force increases as muscle length exceeds the resting length. Active force is generated by elastic properties of titan. So which of the following statement are true about active and passive force? So basically, what is active and passive force? So active force is the force generated by active force is the force generated by muscle. Do it what we have discussed now. That is the actin myosin cross bridge interaction doing a contraction. And what is a passive force? Passive force is the force developed uh, what to say, without this actin myosin cross bridge formation, and only due to the when it is stretched without active contraction. So here uh, option A, that is active force depends on ATP for cross-bridge cycling. This one is true because active force is the force happening due to cross-bridge formation. So cross-bridge formation is uh, facilitated by ATP. So first statement is true. Then passive force relies on contractile elements in muscle. No. Passive force is developed when uh, muscle is stretched without this contraction. So second one is wrong. Third one, passive force increases as muscle length exceeds the resting length. This is true because passive length forms due to the stretching without contraction. Last one, active force generated by the elastic properties of titanium. No, active force is generated by cross bridge interaction due to calcium and Ca2 plus and ATP, not titanium. So we have two statements true for the question. So whenever you are attending the exam, here the question itself gives a hint that uh, is or are, that particular portion of the question itself is giving hint that there is multiple answers true, but sometimes it will be just is or are correct will be there, is correct will be only will be there, but there will be multiple uh, answers for one single question. So do try to check whether there is more than one options you can select. Next question. Next question is regarding the joints. Which of the following statement are true regarding the sternoclavicular joint and glenohumeral joint? Statements are: the ST joint connects the upper limb to the axial skeleton. Second one, the GH joint allows a wider range of motion than ST joint. Third one, both joints are ball and socket joints. The GH joint has greater stability than ST joint. If you can recollect what is ST joint, that is sternoclavicular joint and glenohumeral joint, then try to answer the questions. Try to answer the question. Okay. So this is the sternoclavicular joint. You can see where it is joining, and this is the glenohumeral joint. Coming back to your question. So the sternoclavicular joint. So if you break down this itself, you can from that itself word itself you can find where is a joint if you are not remembering. The sternum is the chest bone. Clavicle is the that neck bone. So where it is happening. So this is that is a C joint connects the upper limb to the axial skeleton. That one is true. And also the GH joint, that is glenohumeral. If you remember where is the humerus, then we will know which is the glenohumeral joint. That is the portion where upper hand is being connected to the body. So GH joint allows a wider range of motion to SC joint. Yes, obviously because the total abduction adduction of the flexion abduction everything of the upper limb is based on glenohumeral joint, whereas this is one linked to the axial skeleton SC joint. And we can see this GH is a ball and socket joint, whereas SC is a saddle joint. So third one is wrong. GH joint has greater stability than SC joint. No, obviously not. If you understand where is GH joint, and most of the people, if you have seen, you might have come across some people who had a shoulder dislocation. So if the GH joint has greater stability, those dislocations won't be happening. So this also is wrong. So answer is option A and B. Next question. Which of the following movements are produced by the trapezius muscle? So if you remember which one is the trapezius muscle? Options are shoulder flexion, scapular elevation and depression, lateral rotation of the humerus, elbow flexion. So which of the following movements are produced by trapezius muscle? Is it shoulder flexion, scapular elevation and depression, lateral rotation of the humerus, elbow flexion? Yes, you are right. Option B, that is scapular elevation and depression. This is the function of trapezius muscle. So this is the muscle in the back of uh, your arm, so in the upper lip towards the wing side. The muscle that running from the end of the neck to midline of the body is what is called trapezius muscle. Next question. The biceps brachii has how many heads? Is it one, two, three, or four? If you had watched the elbow problems, then in that problem itself, we are discussing how many heads are there for biceps brachii. So how many heads are there for biceps brachii? Yes, there are two heads for biceps brachii. Which one is it? One is long head and other one is short head. Next question. Which of the following is responsible for flexing the distal interphalangeal joints, that is dip joint of the fingers? So which of the muscles is responsible for flexing the distal interphalangeal joints, which is known as dip joints of the fingers? Options are flexor digitorum superficialis, flexor digitorum profundus, flexor pollicis longus, extensor digitorum. If you remember the videos, there is two flexor and one extensor. So here the question is giving itself one hint, the flexing of distal interphalangeal joints. So in the option there are three flexors and one extensor. So you only have to choose between three flexors. What might be the answer? The answer is second one, flexor digitorum profundus. So this is the image for flexor digitorum profundus. So it runs from the elbow to the digits, that is the fingers. Here you can see the connections, and this facilitates the flexing of fingers. Next question. The thick filament is attached to the Z disc by which of the following? Options are troponin, ryanodine receptor, titin, tropomyosin. So we have discussed there are two filaments, thick filaments and thin filaments. How thin filaments are being attached to Z disc we have already discussed. So here the question is how thick filament is attached to the Z disc. Is it by troponin or ryanodine receptor, titin or tropomyosin? Answer is option C, titin. So you remember these are the thin filaments and this is the thick filament. So the thick filament is being connected to Z disc, that is this side. The Z disc is through something called titin. So these are thin, thick filament. There is a Z disc. Thin filament itself connected to the directly connects to the Z disc, whereas the thick filaments, that is the myosin filaments, are being connected using something called titin. Next question. The pulling of actin by myosin heads following hydrolysis of ATP is known as. This word we have already discussed in our today's session. What is the word we use for the pulling action of actin by the myosin heads following the hydrolysis of ATP? Is it cocking, rigor, sliding, or power stroke? What is the word we use for pulling action of actin? Yes, option is option D, power stroke. Next question. In the presence of calcium, what happens? Troponin undergoes a conformational change, moving tropomyosin, exposing actin binding sites. Or is it tropomyosin undergoes a conformational change, moving troponin, exposing myosin heads? Or is it troponin undergoes the conformational change, moving tropomyosin, exposing the myosin heads? Or is it tropomyosin undergoes the conformational change, moving troponin, exposing the actin binding sites? The answer is first option, that is troponin undergoes when the calcium ions reaches troponin, it undergoes the conformational change. It shifts or moves the tropomyosin, which eventually exposes the actin binding sites. So, if you remember this relation, that is calcium is the one binding with troponin, then you can easily eliminate the one starts with the tropomyosin. These two. Only uh, these two will be the remaining options. From that, you can uh, choose the right one. Next question. Force produced in a muscle fiber depends on which of the following. Options are the number of sarcomere in series in the myofibril, both average force of its sarcomeres and number of sarcomeres. Next option, average sarcomere force. Next one, number of sarcomeres in parallel. So, force produced in a muscle fiber depends on which of the following. Try to answer the question. right answer is option D. None of you made it correct. First is number of sarcomeres in parallel. That is, this is the sarcomere structure. So these blue lines are actin filaments, and red lines are red thick lines are myosin, and this is the sarcomere. So the force the the force will increase only if the number of sarcomeres in parallel is more. So because if you remember how the force is being developed by the contraction of the force. So if the series being, even though if the sarcomeres are the series configuration, if you are thinking, that is the sarcomeres are one after another. So the contraction will, the effect of the force will be reduced. So the more number of sarcomeres in parallel will give you more force. So that's why the muscle building thing is there. Next question. Which protein is responsible for storage of large amount of calcium in sarcoplasmic reticulum? So this one is a deep question. Which protein is responsible for the storage of large amount of calcium in sarcoplasmic reticulum? We will be remembering the sarcoplasmic reticulum will be releasing calcium ions, but where it is being stored, that everyone may not be remembering. So this question is on that particular thing. The options are titin, calci, calciquestrin, ryanodine receptor, tropomyosin. But the options gives it away. You can easily guess the answer. Which protein is responsible for the storage of large amount of calcium in sarcoplasmic reticulum? Yes, option B, that is calciquestrin. So it is simple. So if you remember that titin is the one we have discussed. It is binding myosin to Z disc. Tropomyosin is in the moving part or shifting part, and ryanodine receptor itself, you can say it's not a protein as such. And also, even if you are not going in that kind of elimination, simply you can just match calcium and calciquestrin. But the options can be a tougher one. Always the options makes it tougher, not the question. For any MCQ, the real villain is the options. If I have given some calcium relating thing, then this kind of elimination will be difficult. Next question. The action potential at muscle fiber is triggered by influx of sodium ions through which of the following? Options are acetylcholine gated sodium channel, voltage gated sodium channels, GABA gated sodium channels, calcium channel. The action potential at muscle fiber is triggered by the influx of sodium ions through which of the following? Can you inbox your answers? No, wrong answer. Okay. Uh, it's not the acetylcholine gated channel. It is voltage gated sodium channels. And gamma is uh, gamma is a neuro inhibitor. Gamma activated butyric acid. So the right one is voltage gated sodium channels uh, facilitates the influx of sodium ions. Next question, which joint connects the upper limb to the axial skeleton? So we just discussed about that question a few questions back. Which joint connects the upper limb to the axial skeleton? Is it acromioclavicular joint, glenohumeral joint, sternoclavicular joint, scapulothoracic joint? Yes, the option is C. That is the sternoclavicular joint. We just discussed it few questions back. Next question. The sternoclavicular joint is classified as which type of synovial joint? Is it plain synovial joint? Is it saddle synovial joint? Is it a hinge joint or pivot joint? That also we have discussed what type of the joint, what kind of joint is a sternoclavicular joint. Yes, that is option B. That's a saddle joint. Saddle joint is something like a horse saddle. This will be the joint. Next question. In the sliding filament theory, the binding of myosin to actin happens when ATP is hydrolyzed, new ATP binds to myosin head, inorganic phosphate is removed, ADP is released. So which one is right? In the sliding filament theory, the binding of myosin happens, binding of myosin to actin happens when, option A, is it uh, when ATP is hydrolyzed, or is it due to ATP binds to myosin head, or inorganic phosphate is removed, or is it when ADP is released? Yes, the answer is when ATP is hydrolyzed. So when this ATP hydrolysis occurs, uh, the ATP hydrolysis occurs before myosin binds to actin and not during the binding. It will because the troponin binding exposes the site. Troponin binding to calcium ions shifts the tropomyosin, and this uh, reveals the myosin binding sites, and the actin gets joined with that. And in between, what our PI, that is inorganic phosphate, removes, and which creates a cocking action, which will cause the myosin heads to move and attach to the actin. So the cascade starts with hydrolysis of ATP. Next question. The acromioclavicular joint is primarily stabilized by which ligament? The question is, I don't remember whether this is discussed in the section, I mean in the videos, but try to answer that. The acromioclavicular joint is primarily stabilized by which ligament? Options are: option A, coracochromial ligament; coracoclavicular ligament; transverse humeral ligament; glenohumeral ligament. Try to answer the question. Our answer is option B, that is coracoclavicular joint. Sorry, coracoclavicular ligament. Option B is our answer. This one. This will be there when this ligament portions are will be discussed in the videos. So for the time being, just remember this one, coracoclavicular ligament. I just put it because it is easy, because only clavicular happens. The question is about acromioclavicular joint, and only option we have in relation to clavicle is option B. Okay, moving to next question. Which joint provides greatest range of motion in human body? Options are: option A, elbow joint; option B, wrist joint; option C, sternoclavicular joint; option D, glenohumeral joint. So that's an easy question. So if you think of the portion of the body which you can uh, move in a lot of degrees of motion, or which joint or which part of the body has greatest degrees of freedom, then it's easy for you to answer the question. So which joint provides the greatest range of motion for a human body? Yes, the option is option D, that is glenohumeral joint. So our hands or upper limbs are having the greatest range of motion in human body, and this greatest range of motion, this much range of motion is mainly provided by glenohumeral joint, that is the shoulder joint, where uh, the upper limb is being, or the humerus bone is being connected to the body. That particular joint is glenohumeral joint, and because of that joint only, the upper limb is having the greatest range of motion. Next question. The glenohumeral joint is best described as. I think this everybody knows. Option A, hinge joint. Option B, saddle joint. Option C, ball and socket joint. Option D, pivot joint. Yes, option C, ball and socket joint. Next question. Which structure deepens the glenoid cavity of the shoulder joint? Options are acromion, coracoid process, glenoid labrum, joint capsule. Options are which structure deepens glenoid cavity of shoulder joint? Box answers. Yes, the answer is glenoid labrum. That is, if you remember, suppose this is the humerus bone. This is the humerus bone, and this is the head of humerus bone coming into this glenoid cavity. This is the glenoid cavity, suppose. So the portion which deepens somewhere here is a portion called labrum. So anything that is related to glenoid cavities, uh, what named with the glenoid, so it is glenoid labrum. Option C is our answer. Next question. The scapulothoracic joint is, options are a true synovial joint, a fibrous joint, option C, a cartilaginous joint, option D, a functional or physiological joint. Yes, options are, it's a functional joint. It's not a true joint. It's a, if you remember what is scapula. Scapula is the that plate-like bone, that triangle-shaped bone behind the upper part of the body. That's which mostly called the wing bone. So this is the humerus. So humerus is behind near, looking from the posterior side. Humerus, this scapula will be covering the head of uh, humerus, and this acts as such. This scapula is not connected to thoracic portion or rib cage through any actual synovial joints. So it is only a, it's this question itself, uh, it's also known as false joint or pseudo joints. So it's not a true synovial joint, and it mostly uh, comes under the classification of a functional joint. Next question, the muscle which initiates the shoulder abduction. Options are, option A, deltoid, option B, supraspinatus, option C, trapezius, option D, pectoralis major. So, what is the abduction motion? So, if you remember what is an abduction motion, then it will be easy for you to recollect which muscle will help in the abduction movement of the shoulder. Is it deltoid, supraspinatus, trapezius, or pectoralis major? Answer is option B, that is supraspinatus. Because if you are, this is the humerus. So shoulder abduction movements, meaning that moving the upper arm away from our body or trunk. So I have already uh, given hint to easy way of remembering this abduction. That is abduction meaning taking away. So moving anything away from the body is abduction. From the medial line of the body is abduction. So abduction means, suppose this is the body trunk, then this direction, motion in this direction is abduction, and uh, so if you remember deltoid is the range of muscles that is here, and supraspinatus is the muscles that is being connected here. So this muscle initiates the abduction. So the if the question was which muscle mostly supports abduction, then it will be deltoid. But which initiates the shoulder abduction is supraspinatus. Next question. Yeah, I just explained that. The deltoid muscle is primarily responsible for which of the motions? Options are shoulder adduction, shoulder abduction beyond initial range, shoulder medial rotation only, option D, elbow flexion. So what is the primary responsibility of deltoid muscle? I just explained the function of deltoid muscle. Yes, that is, this is supraspinatus. This initiates the adduction movement, but after beyond one particular level, the uh, what lifting or taking of the uh, upper arm is being facilitated by this deltoid muscle. The deltoid muscle does not initiates, but it supports after initial abduction movements. So option B is the answer. Shoulder abduction beyond initial range. Next question. Which muscles assist in elevating the scapula? Options are option A, pectoralis major, option B, subclavius, option C, trapezius, option D, deltoid. So the question is, which muscle assists in the elevating the scapula? Yes, answer is option C, trapezius. And suppose so this is the scapula bone, and we are looking from the posterior right, and the muscle group that is covering all this area, that is from back portion of the neck to this much portion, is known as trapezius. So elevation of this scapula is with the help of trapezius muscle. Next question. The primary function of the subclavius muscle is to which of the following? Options are A, abduct the shoulder, B, depress and stabilize the clavicle, option C, elevate the scapula, option D, rotate the humerus laterally. So which is the function of subclavius muscle? Yes, answer is depress and stabilize the clavicle. So if this is the humerus bone and this is the clavicle bone, Here is the subclavius muscle. So this is actually depressing and stabilizing the clavicle bone. Next question. The elbow joint is a combination of, options are hinge and saddle joints. Option B, hinge and pivot joints. Option C, ball and socket and pivot joint. Option D, plain and hinge joint. So, which category the elbow joint will fall in? Which combination is a elbow joint? Yes, option is option B, that is hinge. This everybody knows what an elbow joint is. Uh, it's a classic example. So hinge you can easily connect to. So from this you can just rule out these two things, that is ball and socket. So only options keeping the elbow, I mean hinge joint you can keep, and from that you can eliminate one by one. And saddle joint is mostly in the inside of the bodies, and plain joint, the places where like wrist and ankle. Uh, so option is option B, hinge and pivot joint. Can anyone tell there is one another name for the elbow joint? You can inbox the word. It is often referred to as trochoglimoid joint. So if you don't know this word, you can just write it down. Trochoglimoid. Trochoglimoid joint. So a combination of hinge and pivot joints. Okay, moving on to next question. The movement occurs at the proximal radio-ulnar joint. Options are option A, flexion, option B, extension, option C, pronation and supination, option D, abduction. So, question is, which moment occurs at the proximal radio-ulnar joint? How you know what is a radio-ulnar joint? So the question is, what is the movement occurring in proximal radio-ulnar joint? So radio-ulnar joint is where the radius and ulna meets. So when there is a hand, sorry, so this is the proximal, that is the towards the elbow. Distal is away from the body. This is the distal end towards the wrist, and this is the radius. Suppose the hand is kind of open towards you, then this is the radius, and this is the ulna. So this radius, this particular joint, that is radio-ulnar joint, facilitates something called pronation and supination. That is this wise movement. That uh, if you are moving hands, if you are kind of uh, showing your hands both sides of your palm, inside and back side of the palm, if you are showing that particular movements are pronation and supination. So this particular movement is being facilitated by radio-ulnar joint. As such, we don't have wrist don't have that Z axis rotation. On our wrist only has X and Y rotation. Z axis rotation is what called pronation and supination, and this is being facilitated by the movements of radii and ulna. Next question. This joint primarily allows which of the following? Options are rotation, option B flexion and extension, option C pronation and supination. Easy question, I just answered your question. This joint facilitate which of the following? Option is option B, that is flexion and extension. So rotation is not the primary function. It is the auxiliary function or second function. The main function is to what bring the uh, move the palm towards our forearm and to away from it. That is the flexion and extension is the primary function of wrist joint. Next question. The radiocarpal joint is classified as which of the following? Options are option 1 plain joint, option B hinge joint, option C condyloid joint, option D saddle joint. So what type of synovial joint is an radiocarpal joint? Yes, it is a condyloid joint. And if anyone is wondering what is radiocarpal joint, it is the point where radius is getting attached to the carpals, that is our wrist joint. I mean, in after wrist, there will be suppose this is the wrist portion, then there will be this kind of bones. That joint is known as radiocarpal joints. This small plate shaped carpals will be there, and how it is being connected to radius joint. I mean, radius. Simply saying, what is the type of wrist joint? Option C, condyloid or ellipsoid joint is the right answer. Next question, which muscle is a powerful adductor and medial rotator of the shoulder? So we have already discussed about abductors. So the question is on which muscle is the powerful adductor and medial rotator of the shoulder? Options are deltoid, trapezius, sternocleidomastoid. Option D, pectoralis major. So which muscle facilitate abduction and medial rotation of shoulder? So the question is adductor, that is bringing closer to the body. So the which muscle is helping to what? Bring closer to the body. Bring your arms or upper limbs closer to the body. That's the question. And also medial rotation. Medial is also towards the midline of the body. Rotation towards the midline of the body. So this you can easily eliminate because we have already discussed that deltoid is raising the hands or abduction properties. And trapezius is on the back side. So it's not easy to rotate backwards our arms. So trapezius is mostly helping with scapula, and sternomastoid is on the neck. And this is the answer. Pectoralis major, that is the muscles in the chest, that uh, muscles that connects uh, humerus towards our sternum. Next question. The sternocleidomastoid muscle primarily act as. I just said the answer. Uh, what is the function of sternocleidomastoid muscle? Options are abduct the shoulders, flex and rotate the neck, stabilize the clavicle, extend the elbow. The sternocleidomastoid muscles are muscles in the neck, and if you remember that, the only thing that related to neck is option B, that is flex and rotate the neck. Abduct the shoulders, two set of muscles are there, deltoid and one another, and elbow is far below the sternum. So anything that is coming near sternum, and if you remember, this particular set of muscles are in neck. So answer is option B, flex and rotate the neck. Next question. The acromioclavicular joint allows which type of movement? Options are option A, large rotational movements, Option B, gliding movements between scapula and clavicle. Option C, flexion and extension only. Option D, pronation and supination. Answer is option B. So if you remember, acromioclavicular joint is the joint where clavicle meets the scapula. So there is one portion of scapula known as acromion. Acromion. Sorry. AC. So the acromion of the scapula is being connected to clavicle by acromioclavicular joint. So the gliding movements between scapula and clavicle is being facilitated by this particular joint. Next question. Which muscles form a rounded contour of the muscle? Sorry, shoulder. Which muscle forms the rounded contour of the shoulder? Easy question. Options are trapezius, deltoid, pectoralis major, subclavius. Yes, option B, deltoid. That is, this is the particular deltoid muscle. So this is the shoulder portion. Then this particular rounded contour at the proximal end of the shoulder is due to the deltoid muscle. So next question, that's the last question of today's session. The stability of the shoulder joint is mainly sacrificed for which of the following? Options are strength, endurance, speed, and mobility. So which one, for which of the following, the stability of the shoulder is being sacrificed? Yes, option D, mobility. Because what? If you remember, the shoulder joint is a ball and socket joint. So why it is a ball and socket joint? So that it could provide more ROM, that is range of motion. Uh, and this extended range of motion and the more range of motion demands ball and socket joint, and this particular ball and socket joint not have that much stability, and that's why it is the ball. It is one part of the body. It gets frequently dislocated. So here what the stability of the shoulder joint is traded for mobility of the shoulder joint. So that's all for today. Thank you for joining. Next session we will be discussing the elbow problems, mechanics problems. Thank you for joining.